Today we're going to discuss solving linear inequalities. A statement which contains an equality symbol between two algebraic expressions is called an equality. There are five types of inequality. We use a different inequality symbol for each type. So number one, this symbol means is greater than. The second one, it means it is greater than or equal to. The third one, which means it is less than. The fourth one, which means it is less than or equal to. And the last one means is not equal to. So number one, in this example, we have x is greater than 3. Or we could say that all numbers greater than 3. So as you can see on the graph, that all numbers is going to the right of 3. And we use the open dot to specify that x is greater than 3, meaning the value of x is not included. So number 2, x is greater than or equal to 2. It says that all numbers greater than or equal to 2. So in graphing, we are going to include 2 as the value. That's why we use close dot and the arrow is going to the right of 2. Number 3, x is less than negative 1. It means to say that all numbers less than negative 1. So the direction of the arrow is going to the left of negative 1 and we use the open dot. Number 4, x is less than or equal to 5. It means to say that all numbers less than or equal to 5. So in graph, the direction of the arrow will go to the left of 5 and we use the close dot, meaning to say that 5 is included. Number 5, x is not equal to 3. It says that all numbers except 3. So in graph, we are going to shade all numbers except for 3. That is why the open circle is on 3. Okay, solving linear inequalities. So I have 3 steps as our guide to solve. So number 1, simplify both sides of the inequality by combining like terms and removing parentheses. Number 2, add or subtract the same expression on both sides of the inequality. And the last one, multiply or divide both sides of the inequality by the same positive expressions. Or multiply or divide both sides of the inequality by the same negative expression and reverse the inequality. So number 1, solve the inequality of 3x less than 9x plus 4 and sketch the solution set. Okay, so following the 3 steps now, so we're going to solve this inequality. So I have first 3x less than 9x plus 4. So transpose 9x to the left hand side. So therefore we have 3x minus 9x less than 4. So 3x minus 9x is negative 6x less than 4. So to solve for x, we have to divide both sides by negative 6. Negative 6. And then this will become x. Since we are dividing negative 6, it is stated on the number 3 step that we need to take the reverse of the inequality. So meaning to say, if you are going to divide a negative number or multiply a negative number, then you have to take the reverse of the inequality. So from less than, it becomes now greater than. Therefore, it is x greater than a negative 2/3. So the lowest term of 4 over negative 6 is negative 2/3. So if you're going to graph it now, so this becomes now negative 2/3, and this could be 0. So we could write here uh, open dot, meaning to say it's not included, and the direction of the arrow is going to the right because x is greater than negative 2/3. So the graph is going to the right. Okay, number 2, solve the inequalities of 4 less than or equal to 3x minus 2 and 3x minus 2 is less than 13. Or you can read this one as 3x minus 2 is greater than or equal to 4 and 3x minus 2 is less than 13. So to solve for that, we need to transpose negative 2 to the left hand side and to the right hand side. So this is what I'm trying to say. So this can be now 4 plus 2 is less than or equal to 3x, and 3x is less than or 13 plus 2. So by simplifying, 4 plus 2 equals 6. So it's less than or equal to 3x and less than 15. So since we have 3 as the coefficient of x, so you have to divide 3 of all the terms. So divide this by 3, divide this by 3, and also this one. So we have now 6 divided by 3 equals 2, less than or equal to x, and x is 5. So this is now the solution for that. So the solution set of this will give us, so the solution set now will give us 2 and 5. So I use the open bracket and the close parenthesis to signify that 2 is included value while 4 is not included. So in graph, so we can do like this. So we have now 2 and 5. So 2 is included value, so we have now a closed dot, and 5 is an open dot. So this is now the graph for that. So next we have solving nonlinear inequalities. To solve inequalities involving squares and other powers of the variable, we use factoring together with the following principle. So the sign of a product or quotient. So number 1, if a product or a quotient has an even number of negative factors, then its value is positive. And the second one, if a product or a quotient has an odd number of negative factors, then its value is negative. Here are the guidelines for solving nonlinear inequality. So number 1, move all terms to one side. If necessary, rewrite the inequality so that all non-zero terms appear on one side of the inequality sign. If the non-zero side of the inequality involves quotient, so bring them to a common denominator. Number 2, factor. Factor the non-zero side of the inequality. Number 3, find the intervals to determine the values for which each factor is 0. These numbers will divide the real line into intervals. Enumerate the intervals that are determined by these numbers. Number 4, make a table or diagram. Use test values to make a table or diagram of the signs of each factor on each interval. In the last row of the table, determine the sign of the product or quotient of these factors. And number 5, solve. Use the sign table to find the intervals on which the inequality is satisfied. Check whether the endpoints of these intervals satisfy the inequality. So this may happen if the inequality involves less than or equal or greater than or equal. Okay, this is the example. Solve the inequality of x squared is less than or equal to 5x minus 6. So using the step number one, we have to move all terms to one side. So we have now to write x squared minus 5x plus 6 is less than or equal to 0. Then after that, step number two, we are going to factor on the left hand side. So the factors of 6 that will give a sum of negative 5 will be x minus 2 times x minus 3 is less than or equal to 0. And the third step is that we're going to find the intervals. So the factors of the left-hand side now are x minus 2 and x minus 3. So these factors are 0 when x is 2 and 3 respectively. So let us try to equate this first to 0. That's what I'm trying to say a while ago. So I will say x minus 2 is equal to 0 and x minus 3 is equal to 0 and solve for x. So x now is equal to 2 and x is equal to 3. The numbers 2 and 3 divide the real line into three intervals. So let me show that one. So if this is now the real number line and this is the value of 2 and this is now the value of 3. So as you can see that this real line is divided into three parts. So the first part, we're in this one. This is the first part. And the second part is this one. And the third part will be this one. So the numbers 2 and 3 divide the real line into three intervals. This side here is the interval will give us negative infinity to 2, and this interval here we have the value of 2 to 3, and this side here is giving us the interval of 3 to positive infinity. So the next step now is we are going to make a table or a diagram. So to determine the sign of each factor on each of the intervals that we found, we use test values. We choose a number inside each interval to check the sign of the factors of x minus 2. Okay, so for example, here on the leftmost, so we can test the value. You can say, shall we say, it's choose 1. Okay, so therefore we can write x minus 2 is equal to, if x is 1 in this part, so we have 1 minus 2 is equal to negative 1, and negative 1 is less than 0. And for x minus 3, we have x minus 3 when x is 1, therefore we have 1 minus 3 is equal to negative 2, and negative 2 is less than 0. So both factors are negative on this interval. Notice that we need to check only one test value for each interval because the factors x minus 2 and x minus 3 do not change sign on any of the three intervals that we found. On this part of this interval from 2 to 3, shall we say x is 2.5. So if x is 2.5, then we're going to have, again, we have x minus 2 is equal to, with x is 2.5, we have 2.5 minus 2. So 2.5 minus 2 is 0.5, and 0.5 is greater than 0. And x minus 3 is equal to 2.5 minus 3. So it gives the answer of negative 0.5, and negative 0.5 is less than 0. And on this interval from 3 to infinity, shall we say if x is 4, then we can write x minus 2 is equal to 4 minus 2, is equal to 2 and 2 is greater than 0, and x minus 3 is equal to 4 minus 3, then 4 minus 3 is 1, so therefore 1 is greater than 0. So, so from here, we can now summarize the table. We can write here now, if this is for the interval, and okay, for this is now the sign of x minus 2, and the other one is the sign of x minus 3. So we have here the first interval, we have negative infinity to 2, and the second interval is from 2 to 3, and the third interval is from 3 to positive infinity. So going back here, we test the value from the interval of negative infinity to 2. I use the x value as 1, so we can write here. So 1 minus 2 is equal to negative 1. So negative 1 is less than 0. Therefore, we can write here now as negative. The sign here is negative. So, and also when the sign for x minus 3 is also this one. When you use 1 as the value of x, so we have now negative 2, and that is less than 0 from the word negative. Therefore, we can write here negative. Okay, now moving on to the next interval, 2, 3, and we use the value of x as 2.5. So 2.5 minus 2 is positive, as I have shown my solution here. That's positive. Next, we have if x is 2.5, so 2.5 minus 3, and that is now negative. Okay, so I have shown it here. That is now negative. And on the last interval, we have from 3 to positive infinity. I tried to use 4, therefore 4 minus 2 is 2, which is now positive, and 4 minus 3 is also positive. So since the operation involved is multiplication, so we have the sign of the product of x minus 2 and x minus 3. So we will just going to multiply. Negative times negative is positive, and positive times negative is negative, and positive times positive is positive. Looking at the diagram, we could say that the table or the diagram of x minus 2 times x minus 3 is negative on the interval of 2, 3, this one. So you can check that the endpoints 2 and 3 satisfy the inequality. So the solution set is x such that x is greater than or equal to 2 and x is less than or equal to 3, or this is just equivalent to open bracket 2 comma 3 and close bracket. So in graphing, so we can just graph in this form. So we have 2 and 3, so these one are close dots. So connect the points. So this is now the solution of the inequality. Okay, next example, solve the inequality of x times the square of x minus 1 times x minus 3 is less than 0. So since these are already in the factored form, so first thing that we're going to do is that let us equate first to 0 and then find the interval of the inequality. So we have first, we have x is equal to 0. Next, we have the square of x minus 1. And the last one, we have x minus 3 is equal to 0. So solve for this, the square of x minus 1. So we just right here x now is equal to 1. Okay, so the value of x now are 0, 1, and the other one is x is equal to 3. So let's find now the intervals. So if you're going to find and write a real line, so we can write here x is 0, this is for 1, and this is now 3. So the intervals now are from negative infinity to 0, and this one is from 0 to 1, and this interval is from 1 to 3, and the last one now is from 3 to positive infinity. So now let us make a diagram. This will be for the sign of x. So I will write first here, and this is for 0, this is for 1, and this is for 3, going there. Okay, so let's take a value that is under this interval. Shall we say negative 1? So when x is negative 1, therefore it's negative. And in this side, from interval from 0 to 1, shall we say 0.5? So this is positive. And this one will be, shall we say x here is 2, therefore it's also positive. And here, shall we say x is 4, so therefore this is positive. And the next one, we have the sign of the square of x minus 1. Shall we say the value of x here is negative 1. So negative 1 minus 1 is negative 2. The square of negative 2 is positive. So let's take the value of x from the interval from 0 to 1. Shall we say x is 0.5? So 0.5 minus 1 is negative 0.5. The square of negative 0.5 is positive. So therefore we write here positive. And for example, here we have 1.5, or shall we say 2. So when x is 2, so 2 minus 1 is 1, so 1 squared is positive. And when x is 4, so 4 minus 1 is 3, so 3 squared is positive. So right there, positive. And the last one, we have the sign of x minus 3. So in this interval, shall we say x is negative 1. So negative 1 minus 3 is negative 4. That is now negative. And this one will be, shall we say, the value of x is 0.5. So 0.5 minus 3, that is now negative. In this interval from 1 to 3, shall we say x is 2. So 2 minus 3 is negative. And the last interval from 3 to infinity, shall we say 4? So 4 minus 3 is 1. That's now positive. And the last one now is the sign of the product. So we have sign of x times the square of x minus 1 times x minus 3. So we just multiply all the sign here. So negative times positive is negative. Then negative times negative will give us the answer now of positive. And this interval here, positive times positive is positive times negative. This is now negative. And the third interval, we have positive times positive is positive times negative is also negative. And the other one here, the last interval, so the product of all that is positive. So these are now the sign of the product. Then we are going to check which of these intervals that satisfy the given inequality. So as we could see that since the given interval is less than 0, so it means to say that the solution set will be these two values, which is the negative and the negative, which will satisfy to the given equality that is less than 0. So since there are two values, then the solution set for this, therefore the solution set is the union of these two sets. So we have 0, 1 and union 1, 3. So then the last example, solve the inequality of 1 plus x over 1 minus x is greater than or equal to 1. So first we are going to transpose 1 to the left hand side. So therefore this can be now 1 plus x over 1 minus x minus 1 because we transpose, then greater than or equal to 0. Now from here, we are not going to multiply the entire equation by its LCM, which is now 1 minus x, because we don't know whether 1 minus x is positive or negative. So we can't tell whether the inequality needs to be reversed. So in that case, class, we're just going to simplify the left-hand side by using the LCD. Or so the LCD of this, so we're just going to simplify the left hand side using the LCD of 1 minus x. So 1 minus x divided by 1 minus x is 1 times the numerator of 1 plus x, that is now 1 plus x, minus 1 minus x times 1, therefore we have 1 minus x. So greater than or equal to 0. Simplifying now the numerator, we can write now as 1 plus x minus 1 plus x all over 1 minus x, that is greater than or equal to 0. Simplifying further the numerator, we can cancel the 1, and the remaining term we have now 2x over 1 minus x is greater than or equal to 0. So next we're going to solve the left hand side. So the factors of the left hand side are 2x and 1 minus x. So let us equate that first to 0. So we have 2x is equal to 0. Then x now is equal to 0 because 0 divided by 2 is 0. And the other one, we have 1 minus x is equal to 0. Transpose x to the right side. Therefore, 1 is equal to x, or x is equal to 1. So the values now is 0 and 1. So if you're going to put that one in a real number line, so this will divide the real number line into 3 parts. So meaning to say, we have 3 intervals. So on this side, we have the interval from negative infinity to 0. And this side, we have 0 to 1. And on this part, or on this interval, we have the interval of from 1 to infinity. So we are going to check now, we are going to test the value. So we can write now the sign. So this is open circle, open dot. This is for 0 and this is for 1. So let us have here. So what's the sign of 2x? So shall we say the value of x is negative 1. So 2 times x, or 2 times negative 1, is negative. So in this interval from 0 to 1, shall we say 0.1, so, or 0.5, so we say 2 times 0.5 is 1, that is now positive. And shall we say the value of x in this interval is 2, therefore 2 times 2 is 4, that is positive. And the next one is 1 minus x. So what's the sign of 1 minus x? So shall we say the value of x here in this interval is negative 1. So 1 minus negative 1, that is positive. This is now positive. And shall we say the value here is zero point 0.5? So 1 minus zero point 0.5, that is positive. And if the value of x here is 2, so 1 minus 2 is negative. Now, this is the quotient because 2x over 1 minus x, so let us have the sign of 2x over 1 minus x. So we are going to divide. So we have negative 1 divided by x is negative, and positive divided by positive is positive, and positive divided by negative is negative. So the sign now of the quotient of 2x over 1 minus x. Now we are going to determine which inequality that satisfy the given, which is greater than or equal to 1. So greater than or equal to 1, that is now positive. So meaning to say that the solution set is 0, 1. So from the diagram, we see that the inequality is satisfied on the interval of 0, 1. Then we're going to check the endpoints. We see that 0 satisfies the inequality, so and 1 does not. So this is what I'm trying to say. We are going to check whether 0 will satisfy to the given equation and also with 1. So when x is 0, therefore 1 plus 0 is 1, and then the other one is 1 minus 0 is 1. So the quotient now, we have 1 over 1, that is 1, and 1 is greater than or equal to 1. So therefore 0 satisfy the given inequality. Now what about 1? So if x is 1, so 1 plus 1 is 2. So we have 2 now is the numerator, and 1 minus 1 is 0. So 2 over 0 is undefined. Therefore, the value of 1 does not satisfy to the given equality. Therefore, okay, the interval of the solution set, it should be, so open bracket, and since 0 is included, and 1 does not satisfy the given equality, therefore this must be a close parenthesis. Again, the solution set now is open bracket of 0 and 1, then close parenthesis.